Algebra 1 lesson 87, we are factoring polynomials by grouping. So with this, we are using a method that we actually talked about when we were looking at our more complex trinomials. We have 4 different terms, and so we need to group them into 2 different parts and look at those common factors. This is like the method that we did where we said I have A and C multiplied together and we have a sum of B, and we split it into those 4 different parts. Well, in factoring by grouping, we already have those 4 different terms. So what we want to do is take, let's say, these first 2 that we have here, and we are going to group them and say what term do they have in common? What factor do they have in common? And we say, oh, I can factor out a 2x here. And so I have x plus 2y left over. And for the second 2, I can see that they have some things in common. They have a 7 in common. So we can say, well, I have an x plus 2y left over, which is good because that x plus 2y is now a common factor between the 2 larger terms. So I can say x plus 2y has been multiplied to 2x plus 7. Taking those from these outside, saying, okay, both of those terms, 2x and 7, have been multiplied to x plus 2y. And so we can say we can check this answer by multiplying it out again. And so I can use like the box method to check my answer, to say x and 2y has been multiplied to 2x and 7. So we get a 2x squared, we get a 4xy, we get a 7x, and we get a 14y, which is exactly what we started with. And so this factoring that we have these 2 binomials is the correct factorization. So let's try it again. Once again, let's group these first 2 terms, and we get a 5x times x plus 2y and 3 times x plus 2y. That x plus 2y is not going to happen every single time. It just happened in these cases. But we say now that common factor of x plus 2y has been multiplied to 5x, and it's been multiplied to 3. So we can check our answer by multiplication, but just know that yes, it will work. You can check for yourself though. Now, what if this were not the order that was given? What if it was put in a different order? Would it still work? So let's maybe try it and say, what if it were in the order of 5x squared plus 3x and 10xy and 6y? Just to see what would happen if this were in a different grouping. And so in the first case, I would pull out an x and say that we have a 5x plus 3 left over, and we pull out a 2 and a y, and so we have left over a 5x and a plus 3, which ends up, we see that this 5x plus 3 is common between now both of our big terms, and we have an x plus 2y left over. So we can see it can happen that we have a different order for this factorization by grouping and it still works. But we have to be a little bit careful because I couldn't go as far to say that I'm going to group together my 5x squared and my 6y. They have nothing in common, so we couldn't be able to factor those 2 together. So we have to be a little bit careful as far as how we group these things together to make sure that we're going to at least get a couple things in common. So for this first case, I would probably want to group some common factors like 5x squared and 5. So I'm going to write those together first, 5x squared and 5. And then I'm going to group together my minus 12x to the third and my minus 12x, because those have things in common, especially those outside numbers and the variables. So in the first case, I'm going to factor out a 5, and we have x squared plus 1. Okay, and for the second one, I'm going to factor out a negative 12x, and so I have an x squared and a plus 1 left over, which means that we have this x squared plus 1 in common between my 5 minus 12x. and that is my factorization. And so you can see how I tried to group some things that were in common between the two. Okay. Now, let's try again, and I'm going to bring together my 3y squared and my 3, and I'm going to bring together my negative 8y to the third and minus 8y. And so I say, in the first case, I factor out a 3, and we have y squared plus 1. And I factor out a negative 8y, and so I have a y squared plus 1. And so I factor and say, my factorization is y squared plus 1 times 3 minus 8y. So factorization by grouping ends up being pretty easy, but we do have to make sure that we are factoring with those common terms. Sometimes we need to regroup things. Now, it can get a little bit more complicated, but not by much. In this case, let's see. In the first one, I'm going to keep it as is. I see some commonalities with a lot of these, but let's see what happens if I were to keep the grouping as it is right now. And in the first case, I can factor out a 15a to the third, so I have left a 3b minus 1. And once again, I can factor out a 5a squared, so I say that I have a 3b minus 1 left over, which is great because I have this 3b minus 1 in common multiplied to this 15a to the third plus 5a squared. Okay? And then in this next case, I'll just do a couple more examples here for you. In this next case, I see that I can maybe in the first case factor out a 6z squared, so I have a 9xz plus 1. And then in the second case, I can factor out a negative 2z squared, and I get a 9z minus or plus 1. Let's see. So in this case, unfortunately, because of this x right here, I'm not going to get something that is in common. So in this case, it cannot be factored by grouping, and so we would actually leave it in this first option right here because we couldn't actually combine it in by factoring here, okay? Because of that x, that kind of messes it up. If that x were not there, then we could actually factor this by grouping. Now I'm going to let you work with a couple of these on your own. Here's 2 more examples that you can factor by grouping, but think about maybe moving things around in order to group them more effectively. Okay? Now, once again, the reason that we do factoring by grouping is because we can actually do this with our normal quadratics as well. Okay, this is a normal, more simple quadratic that we have said in the past, what can multiply to give me negative 44 and add to give me negative 7? Well, in that case, we can say that negative 11 and 4 would work. So we split it up to x minus 11 and x plus 4. Now, if we have a more complex trinomial, like 6k squared minus 17k plus 10, we want to do the same thing, okay, but it just gets slightly more complex. We say a times c, which is 6 times 10, so 60, and a sum of b, so negative 17. And in this case, we see, well, we are going to make it so that we can factor by grouping. By taking what multiplies to give me 60 and adds to give me negative 17, so we have a negative 5 and a negative 12, and we split this guy up to say we have 6k squared minus 12k minus 5k plus 10, which ends up giving us now something I can factor by grouping. In the first case, I can factor out a 6k to have k minus 2. And in the second case, I can factor out a negative 5 to have a k minus 2. And so I see that my factorization for this is 6k minus 5 times k minus 2. And you can try that on the second one here. But you can take these more difficult quadratics and factor them by grouping by using A, C, and B, finding your two different numbers that work, and splitting it into those 4 different parts. All right, well, I hope this helps for your homework and for studying.